Dear students, welcome to my class on waves. There are two ways by which energy can be transported from one point to another. Firstly, the transport of energy from one point to another involves the actual transport of matter. Secondly, there is a method in which energy can be transported from one point to another without the actual transfer of matter. Can you see two figures in this presentation? The first image shows a bullet which is fired from a gun. That bullet carries a lot of energy with it and it is transported from one point to another. There is actual transport of matter. What is that in the second image? There is a transport of matter from there is a transport of energy from one point to another without the transport of matter. That is possible through the agency of waves. So what do you mean by wave motion? We can hear when a violinist plays his violin from some place, its sound is heard at distant locations. Also, when a stone is dropped on a still water of a lake or any water body, we can see ripples which will be formed on the surface of the water body, and water moves steadily in the outward direction. And also there are waves which occur due to the vibrations of the earth, which is quite significant during earthquakes. Then we know that there are electromagnetic waves which consist of electric and magnetic fields which travel through space without the need of a medium. Such waves are known as electromagnetic waves. Electromagnetic waves include visible light which comes from our bulb, then it includes radio waves which come from a radio station, then we have microwaves, infrared rays, ultraviolet rays, X-rays, gamma rays, etc. So all these various processes include transport of energy in different ways, but they have something in common. What is that? The common feature is that we can refer to all these phenomena as wave motion. All these processes involve wave motion, or in all these processes energy is transferred from one point to another through the agency of waves. Now we will see how a wave is formed and how it is propagated. If you drop a stone on a water body or a lake, you can observe that ripples are formed that spread out from point where the stone strikes the water surface. Can you say whether the water actually moves along with the ripples that are generated? How will you find out that? For that, make a small paper boat and place it on the water surface and observe how it moves. What will happen then? The paper boat just bounces up and down at the same place on the surface of the water and does not move with the ripples. Why? Because the water particles are undergoing oscillatory motion without any translational motion. So the paper boat cannot move from one point to another. It will just bounce up and down at the same place where we dropped it. That is a disturbance which is caused at the point of contact of the stone with the water surface, and it is progressively transferred to the adjacent water particles due to the oscillatory motion. Now another example is you take a long and thin elastic string, then fix it on one end of it is fixed to a wall, then hold the other end, stretch it and taut. Now quickly move your hands up and down, your single hand up and down. What will you observe? A disturbance will be traveling along the length of the string. This disturbance refers to the deformation of the shape of the water surface or any other medium such as string, air, etc. with respect to the undisturbed surface. That is, the disturbance is transmitted from one point to another, not the particle of the medium. Something created a disturbance on the particles of the medium, and that disturbance is transferred to the adjacent particle, and in such a way that disturbance is transported from one point to another. Thus, our energy might be transferred from one point to another through the agency of this disturbance. Now we can define wave motion as, or a wave as, a disturbance that carries or transports energy and momentum without the transport of matter. Energy and momentum can be transferred from one point to another without the transport of matter through the agency of wave. Thus, wave motion involves transfer of disturbance from one point to another with the particle of the medium oscillating about their mean position. Like in the water particles will be oscillating about its mean position. The disturbance will be transferred from one point to another. Thus, energy and momentum will be transported from one point to another. The medium as a whole does not go in the direction of movement of the wave. Water particles are not transported from one point to another, or the particle of the string are not transferred from one point to another, only that it is oscillating about its mean position, and that disturbance alone is transmitted from one point to another. Along with that disturbance, energy and momentum is transported from one point to another. That is what is wave. That is what is a wave called. So, a wave is a disturbance which carries or transports energy and momentum without the transport of matter. Now, waves can be classified into different types of waves, and these classifications are also different types of classifications are also there. Some important types of classifications are, one is like the first one is classification based on the medium of propagation of the wave. Based on the medium of propagation of the waves can be classified into different types. Secondly, waves can be classified depending on the shape of its wavefront. Then it can also be classified depending on the dimension of propagation of the propagating medium, or depending on the dimension of the propagating medium, waves can be classified into different types. And also depending on the direction of vibration of the particles of the medium, waves can be classified into different types. So mainly there are 4 types of classification. One is based on the medium of propagation, the other one is based on the shape of the wavefront, then a third one is based on the dimension of propagation, then the fourth one is based on the direction of vibration. Now first we will see how waves are classified on the basis of the medium, on the basis of the need for a medium of propagation. Some waves need a medium for its propagation, and some waves do not require a medium for its propagation. They are classified into 2 types. One is mechanical waves and the other one is non-mechanical waves. So what are mechanical waves? Obviously, mechanical waves are waves which require a material medium for its propagation. Material medium means medium which are having elasticity as well as inertia, like solids, liquids, gases, etc. So mechanical waves can be propagated through a solid medium or a liquid medium or a gaseous medium. There are many examples for mechanical waves. One is sound wave, then we have water waves, then waves along a string. These are all examples of waves which are transmitted through a medium. Now, secondly, we have non-mechanical waves, which are waves which do not require any material medium for its propagation. An example for non-mechanical wave is electromagnetic waves. Electromagnetic waves, all electromagnetic waves are non-mechanical waves, that is, they can be transmitted from one point to another without any material medium for its propagation. That is why we can say that light from sun reaches the earth without any medium. It can travel through a region where no medium is present. Now, second type of classification is based on the shape of the wavefront of a wave. Wavefront, what do you mean by wavefront? It is a locus of points having same state of vibration. So, depending on the shape of the wavefront, waves can be classified into plane waves, spherical waves and cylindrical waves. The plane waves are waves which are having wavefronts which are having the shape of a plane. the wavefront will be plane, then such waves are known as plane waves. If the wavefronts are in spherical shape, then such waves are known as spherical waves. If the wavefronts are in the shape of cylinder, such waves are known as cylindrical waves. Then the third classification is based on the dimension of the propagating medium. Depending on the dimension of the propagating medium, waves can be classified into three types. One is the one-dimensional wave, the second one is the two-dimensional wave, and then we have the three-dimensional wave also. As name suggests, one-dimensional waves are waves which are transmitted through one-dimensional medium. What is a one-dimensional medium? A line is one-dimensional. So waves which are propagated along a line is a one-dimensional wave. An example is a string. Waves transmitted along a string is transmitting through a line. That means it is transmitted through a one-dimensional medium. So such waves are examples for one-dimensional waves. Waves transmitted through a string or a spring, etc. are examples for one-dimensional wave. Any wave which is transmitted through a one-dimensional medium is known as a one-dimensional wave. Secondly, we have two-dimensional waves. Two-dimensional waves are waves which are propagated through two-dimensional medium. Two dimensions means a surface. So if a surface will be having two dimensions. So if a wave is propagated along a plane or a surface, then such waves are known as two-dimensional waves. An example is our water waves. Water is propagating along the surface, so it is a two-dimensional wave. Then waves along any membrane will be, membranes are surfaces, so waves propagated along any membranes will be two-dimensional waves. Then finally we have this three-dimensional waves. Three-dimensional waves are waves which are propagated through three-dimensional medium. Three-dimensional medium, we have many examples. All the electromagnetic waves, they are propagating along three-dimensional medium. Then light from a candle, then the microwaves, radio waves, all the electromagnetic waves are transmitted through three-dimensional mediums. Then our sound wave, all are examples of three-dimensional waves. So waves can be classified based on the dimension of the propagating medium into one dimension, two dimension and three dimensional waves. Now there is another classification which is an important type of classification, and it is based on the direction of vibration of the particle of the medium relative to the movement of the waves or relative to the direction of propagation of the wave. Waves can be classified into two types. They are transverse and longitudinal waves. Waves can be classified into transverse and longitudinal waves. So what are transverse waves? In transverse waves, particle of the medium oscillate perpendicular to the direction of propagation of the wave. Wave will be propagating along a particular direction. Particle of the medium will be oscillating in a perpendicular direction. Then such waves are known as transverse waves. An example is transverse waves in a rope or in a string. If the rope is fixed at one end, then the other end is stretched with our hand, and if we move the rope up and down, we can observe that a wave will be transmitting along this direction, along a perpendicular direction. Rope will be moving in the up and down direction, and the wave will be propagating in a perpendicular direction. Such waves are known as transverse waves. Such waves travel in the form of crest and trough. Crest means the upward peak is known as crest, and the downward peaks are known as troughs or valleys. Then electromagnetic waves are also examples of transverse waves, but that is not due to the direction of oscillation or something, because as you know, electromagnetic waves do not require any material medium for its propagation, but they are transverse also. That is because in electromagnetic waves there is an electric field, then there will be magnetic field. Both these fields will be perpendicular to each other, and that will also be perpendicular to the direction of propagation of the wave. Both the directions of electric and magnetic fields will be perpendicular to each other and also perpendicular to the direction of propagation of the waves. That is why electromagnetic waves are known as transverse waves. Now we have longitudinal waves. So what are longitudinal waves? Obviously, longitudinal waves will be waves in which the oscillation of the particle is parallel to the direction of propagation of the wave. Waves in which particle will oscillate in a particular direction, wave will also be transmitted along the same direction. Such waves are known as longitudinal waves. In such waves, waves travel in the form of compressions and rarefactions. Compressions and rarefaction. Instead of crest and trough, here we have compressions and rarefaction. An example is a spring. If a spring is fixed at one end, and if you hold the spring at the other end, and if you do move it like this, a wave will be propagating along the same direction as the oscillation of the string. Since the oscillation of the spring and the wave is along the same direction, such waves are known as longitudinal waves. Longitudinal waves travel in the form of compressions and rarefactions. Both these transverse and longitudinal waves can exhibit phenomena like reflection, refraction, interference, diffraction, scattering, etc. But the major difference is that only transverse waves can be polarized. That is, only transverse waves exhibit the phenomenon of polarization, whereas longitudinal waves cannot be polarized. Not that point, transverse waves can be polarized, whereas longitudinal waves cannot be polarized. Our water waves is a combination of both longitudinal and transverse waves. Sound waves are also examples of longitudinal waves. Now we'll move on to the characteristics of a wave. What are the different characteristics of a wave? The most important characteristics of a wave is its frequency, wave frequency. In the case of waves, the frequency can be defined as the number of waves produced per second. Number of waves produced per second is known as frequency of the wave. Frequency, it is same as the frequency with which particle of the medium oscillate. So the particle of the medium will oscillate with a particular frequency. The same frequency, waves will be transmitted through the medium. So in transverse waves, frequency can be defined as a number of crests or the number of troughs that pass through a point in 1 second. In longitudinal waves, this frequency is the number of compressions or rarefactions that pass through a point in 1 second. Usually, frequency is denoted using a symbol nu or f. N is also used in some places. The SI unit of frequency is hertz, which is equal to 1 cycle per second. So usually we use per second also as the unit of frequency. Then next important property of a wave is wavelength. What is a wavelength? Distance. Here in this figure you can see that there are two adjacent crests. The distance between the midpoints of these adjacent crests is equal to the wavelength of this wave. Or in general we can define wavelength as the distance between any 2 points in the same state of vibration is known as the wavelength. Wavelength is equal to the distance between two consecutive crests or two consecutive troughs. Always wavelength is denoted by the letter lambda. Lambda denotes wavelength, and lambda is having the unit of distance. Then we have another characteristic that is known as a time period. Or the time period of the oscillation of the particle in the medium is the time period of the wave. So time period of the wave is same as the time period of oscillation of particle of the medium. It is also denoted as T, capital T. We all know that frequency is the reciprocal of time period, or T is equal to 1 by F. Actually, wavelength and time period represent the spatial and temporal properties of a wave respectively. Wavelength represents a spatial property of a wave, whereas time period represents the temporal properties of a wave. Then we have amplitude. Amplitude of a wave is equal to the maximum possible displacement of the particle from their mean position. When the particle oscillate, they will have an amplitude. They will be having a maximum displacement. That value is equal to the amplitude of our wave. Amplitude of the wave is same as the amplitude of oscillating particles. Then another important characteristic of a wave is known as phase. Phase describes the state of motion of the particle on the wave. The state of motion of particle of the wave is described as phase. Mathematically, it is the argument of the periodic function representing a periodic wave. We will later see that a periodic wave can be represented using a mathematical function which will be a periodic function, and the argument of that function will represent the phase of this wave. Now we have another property, that is phase velocity. Velocity of the wave motion, or the distance covered by a wave in 1 second, is known as the phase velocity. It is usually represented as Vp, that will be equal to frequency into wavelength. F lambda will be equal to the phase velocity. Can also be defined as omega by k. Then we'll see what omega and k are. Omega is the angular frequency. Angular frequency is the time rate of change of phase. Omega will be equal to 2 pi by t. Time rate of change of phase is known as angular frequency. Then we have k, which is a wave vector, which is also an important characteristic of a wave, that is the space rate of change of phase.